Let's welcome Sir Philip Campbell.
Thank you very much. It's a great pleasure to be here to tell you about what I'm going to call transformative research and how we can support it. And I'm also going to focus on young scientists especially, in the hope that some of you, the younger ones amongst you, will be inspired to know that you can make a real difference, even if you're young. I'm going to talk about how researchers sometimes succeed in transforming knowledge for its own sake, and or making the world a better place, and how to help these people. So let me first give you an example of transformative basic research. So this is a person who has been shown on this screen twice already today, which just shows how consistently he inspires people. Einstein was 26 when he produced some miraculous work in 1905. And one of the pieces of work he produced was the theory of special relativity, which really began to rethink the way in which we humans think about mass, energy, speed, the way the laws of physics work for everyday objects, albeit in sometimes extraordinary circumstances. And then less than 10 years later, as you've heard from Kip Thorne, he produced the theory of general relativity. And as with special relativity, what fascinated me when I was a young person wanting to become a physicist, and what fascinates many people, is the way in which these were almost pure thought. The application of really critical thinking by Einstein, very creative thinking, but just thinking about what happens, for example, if you travel on a beam of light. And just thinking about things like that led him to these extraordinary transformative ideas. And then, as we've also heard, in 2016 there were published the results of the first detection of gravitational waves, and here's a picture that I took off the web. If only Einstein had been around to enjoy it, as shown here. But what's also fun about really basic research, really fundamental research, is how it can have an impact on the world, and indeed the everyday world, even though relativity is often applied to the most esoteric situations, like extremely high velocities or deep gravitational potential wells around black holes. If you look at the satellite navigating system, if you look at the way in which signals are transmitted from multiple satellites into your iPhone or your other, whatever phones you have, to give you your position on the surface of the Earth, that depends on a number of things correcting for errors. And if you look at all the different sources of errors, buried amongst them are one for special relativity, which, because the satellites are traveling fast, tends to make clocks on the Earth go slower. And if you look at general relativity, you find that clocks are going faster. So what you are trying to do is correct for a total of about 30 or 40 microseconds a day in order to make the satellites give you the right position. And it's because of general and special relativity and the theories that Einstein produced that we can get that right. For young academics coming into research, you find, I'm going to be very simplistic here, two types. There is one who is the sort of person who wants to really probe the nature of the way the world works, the laws, whether of physics, of biology, of chemistry. And that is the world in which I grew up. But then there are also, increasingly, I think, young people coming into research who really want to change our relationship with the world. And a key point I want to make is that to support those people, you need to think a little bit differently. Because if you're going to have your research make an impact, you have to work with the people who are going to help make that impact. As you heard in the previous talk, we're all in it together. So you need to talk to the people who will be affected by your research as you dream up the project in order to understand what you need to deliver that's going to make that direct impact. And that's something I want to emphasize. These people are trying to make a direct impact from their research. So I'm going to give you an example that couldn't be more different from the sort of research you've heard about already. This is about transport. It's about transport in cities. As it happens, near where I work in London is Imperial College. And there is a laboratory for the study of transport systems. And they have reported work, which they did over 10 or 15 years, that has really made a difference around the world to the way metro systems are operated. And this picture is of the Chinese metro system, which is one of the operations that was positively benefited by the work they're doing, and probably still is. So an analysis of their work showed that the savings in operating costs that had been made around the world over 10 years were of the order of £500 million. And in terms of the societal benefits that flowed directly from their work, there was that financial saving and all the benefits that gives. There were the operational practices around the different metro and bus systems in terms of very prosaic things like how you maintain your elevators and your escalators and so on. There were government policies that were implemented. This policy has an impact not just on the high-flying policymakers, but on the way in which you are charged for using public services, for example. And then there was another aspect of this which I want to just mention, research co-production, which is jargon. But what it means is where you, the researcher in academia, work from the very beginning of the project with the people who are going to be your bridge to the public, and indeed sometimes also the public themselves. And they help you frame the project at the very beginning. So this example of co-production, at the early stages of this project, they formed 5 global consortia comprising over 70 companies of metro, suburban rail, and urban bus operators. And they had exchanges in a very formalized way, but in a very free-flowing way, between the researchers and the users from the outset, co-production. And to me, this reflects a very strong academic engineering research culture. This co-production, and what you value is not only insights and innovation, of course, but also the fitness for purpose that you end up with. And also, one hopes, some prestige that comes from that societal impact, as well as from any academic publications you may produce. And that, too, is something that a culture change needs to be thought about. How you recognize the value of research needs to be broader than traditional. So what are the challenges in doing useful research and the sort of support that's required? So one is the actual co-production. So this is a special issue of Nature that we produced quite recently, where we looked at many examples of co-production in practice. When I talk to funders of research around the world, I find that many are beginning to recognize the value of this in many areas of research, because usefulness, societal impact, is becoming more important in government policy. So they're all having to think about it, and they're recognizing as funders that they need to support this. And many are putting money into this very process of participation and collaboration. But very few of them are allowing more time for it. It can take up to a year of extra thinking just to work out what this project has got to be about if it's going to succeed. And very few governments and funders are recognizing that need. We need to change the incentives for young researchers. This is a group of young researchers who were working in cities research. They were attending a conference at the UN University. And I'm just picking them out from the web as examples of people whose work depends on making a societal impact. That's what they're trying to do. And yes, they might publish in well-respected journals, but the way in which they are assessed probably isn't going to do justice to that societal impact the way things are at the moment. So changing those incentives to include, not to replace, but to include more societally oriented criteria is important. And then we, the editors and publishers, also need to adapt. So I'm the editor-in-chief of this company, Springer Nature, and we have 4 main publishing brands inside the company. Springer, which covers in all the disciplines, Biomed Central, which started off at least as a biomedical company, Palgrave Macmillan in social sciences, and Nature Research. And Nature Research is the company that houses all of the Nature branded journals. So in the Nature group, we've been increasingly producing journals that aim to be societally useful. Nature Plants, Nature Energy, Nature Climate Change, Nature Ecology and Evolution, Nature Geoscience, and Nature Sustainability and Nature Human Behavior. And I put those vertically because they are actually straddling all of these challenges. Sustainability as a general topic, and also human behavior, incredibly important. So what do you find when you start publishing this sort of stuff compared to the stuff we're used to publishing, which is more basic science? You find you have interesting types of content that you're not used to. Now, I want to stress the fact that we are doing this is not in itself a profound innovation in publishing. There are many other publishers who've been doing this sort of publishing for a long time. But I do want to highlight, because there is so much emphasis on the brands like Nature, like Science, like Cell Press, in academic prestige, that we are broadening our reach into including this sort of research. So look at the title, if you can read it, of the first paper. This is a proper research article, and it is entitled "Dismissive and Deceptive Car Dealerships Create Barriers to Electric Vehicle Adoption at the Point of Sale." So this is an interesting sort of paper that's looking at the behavior within the transport and energy system of people who, not really knowingly, are obstructing progress. They're obstructing sustainability because of the way in which car dealers work. So for us to be publishing research like that could have an immediate impact, and it's a great joy to actually deal with those types of human problems rather than simply the sort of work that you see at the bottom right of this, which is equally important as far as I'm aware, which is looking at the particular ways in which you can make solar cells. That's more traditional. It is important in the long run, but I wanted to contrast those two types of research. To finish off, I want to focus on the brain. So the brain is an interesting organ because it's inherently fascinating. It helps make humans what they are, but the gulf between our understanding and our ability to explore the actual inner workings of the brain, the gulf between that and what actually happens in human behavior and human disease is huge. Despite years and decades of neuroscience, the neuroscience has made fascinating developments, but it's made very little difference so far to our understanding of how to help people be better. And you could say the same about cancer research a couple of decades ago, and cancer research has made enormous progress now. So I'm not in any way saying that neuroscience is not important, far from it. So I want to give examples of a piece of basic neuroscience and technology that is transformative and was done by young researchers. So this is the phenomenon of neurons triggered by light. This idea was first speculated about by a great scientist, Francis Crick, at the turn of this century. And it wasn't at all clear when he speculated about it, about how it might turn out. But then people began to explore how you could actually activate the cells in our brains by light. And they did it with some very clever molecular and cell biology. And here's an example, just a picture of what people are doing in the lab right now using mice. And I want to highlight two young scientists who are not the only young scientists in this area, or old scientists. There are many other people who've made tremendous innovations. But these two were right at the heart of the bit of work that really made it applicable in the lab. So Ed Boyden is one of them. He's at the MIT, and he won the 2016 Breakthrough Prize in Life Sciences for the development and implementation of optogenetics, using light to activate neurons and the circuits that neurons are a part of. And he shared that with Karl Deisseroth, who's at Stanford University, and he too won exactly the same prize. They were working together at the early days of this technology in the same lab, and Ed Boyden was still a student, and I think Karl was his supervisor, but they were both very young in their development as scientists. Karl is interesting because he's driven by mental illness and the understanding of it, because he is a clinician who works with people suffering from psychiatric disorders. However, it's going to be a long time until the work that he does in the labs looking at mice is going to make a direct difference on his clinical work. So I want to talk about a very different approach to the brain and to looking at brain disorders and treating them. So I wanted to highlight just one young researcher working to transform mental health and consequently physical health in remote African villages. And I've come across this person because we funded her in a charity that I'm a part of called MQ, Transforming Mental Health. That's a fundraising charity based in Britain, but we fund internationally. And this was one of the people who we funded as a young researcher. So her name is Etheldreda Nakimuli Mapungu, and we call her Ethel for short. And she's at Makerere University in Uganda. That's her. And on the right, you can see a picture of her and colleagues in action in a village, working with villagers who are suffering, some of them anyway, from HIV and from anxiety and depression. And one of the things that is interesting about the way these diseases work is that they feed off each other. If you have HIV, it can cause depression, and depression can hinder your ability to tackle your physical disease. So I like to think of her as someone who is also transformative. She hasn't had that large impact that the other work I've discussed has had yet. But she's been celebrated at the World Economic Forum, at the World Bank, and in other places. You'll find her on YouTube if you look. She gave a TED talk. So she's having that sort of an impact at least. And she's out there actually solving the problems today in villages. It is innovating healthcare, and it is also breaking down some barriers. It's breaking down barriers of stigma, because in villages like this, you don't necessarily easily talk about suffering from these sorts of conditions. But by going in and by helping people to talk, she's able to do that. It's also breaking down silos between treatments for physical and mental disorders. Now, the work she's doing and the people who are going to take her work forward in the villages are not sophisticated medical people. They're not sophisticated clinicians or psychiatrists. They are rural health workers. And another of the innovations that she is introducing is how to help those sorts of people use the techniques of talking therapies, for example, to help villagers. So it's not just her, it is people she has trained. And then to see how that scales up, perhaps with the help of remote communications technologies, is going to be a fascinating journey. And she's also breaking down barriers of poverty and rural remoteness. There she is, out in the villages in Africa. And the burden of poverty is also something to think about. What you've seen today has been some fantastic technology. Technology can make a huge difference, but so too can changing society's conditions. Just the act of reducing poverty, which is one of the United Nations Sustainable Development Goals, just the action of reducing poverty will make itself a tremendous impact on human suffering. So let's not forget that it is not just about technology or about academic research, but it is also changing the conditions of society for millions or even billions of people. So how do you incentivize young researchers? I talked about this. I've given examples of prizes. A lot of the prizes that are out there are for fundamental research. So we thought it would be a good idea to introduce a prize that is specifically rewarding impact-making research of the sort I've talked about, carried out by young scientists. And by young scientists, I mean scientists who are just at the point of taking on their labs or have been doing that for a few years. So that's what I mean by young. So I'm very pleased to announce that we are going to introduce this prize, the Nature Research Group, in partnership with Tencent. The awards are going to be called the Nature Research Awards for Driving Global Impact. As I say, Tencent is our partner in this. And in 2019, this competition will focus on brain science. And that's why I gave you some examples of what young scientists can do in looking at the brain from so many different ways. I think you're about to see a video about this prize, and I want to thank you very much for your attention.